All right, I'm going to talk to you about arithmetic sequences. And an arithmetic sequence is when there is a series of numbers that are a pattern where there is a common difference, something that you are adding or subtracting every time. So in this first example I have, if you look, you see that we are adding 2 here, adding 2 here, and adding 2 here. So because the common difference is 2, then this is an example of an arithmetic sequence. With this next example, you see that we are adding 3, but then we are subtracting 2, and then we're adding 5. So because there is not a common difference here, this is not an example of an arithmetic sequence. All right, so I'm going to start with this example here. So we have 4 terms. And so the first term is 10, the second term is 13, the third term is 16, the fourth term is 19, and so on. Excuse me. The first thing I can do is I need to determine whether or not it is an arithmetic sequence. And this is because you notice that we are adding 3 to each term. Okay, so here the common difference is 3. If I wanted to write the formula for this pattern, a recursive formula, it would look like this. A sub n, where A sub n stands for whatever term it is that we're looking for, is equal to A sub n minus 1 plus the common difference, which in this example is 3. So I'll put plus 3. And my first term is 10. The recursive formula is not really used to determine anything, to find anything, other than it just gives you information. It just tells us our first term, which is 10, and it tells us the common difference, which is 3. But I can't use this to find the 20th term, because if I tried to, so let's say we wanted to find the 20th term, okay, so a sub n, the 20th term, is equal to 19, because n is 20, and 20 minus 1 is 19, plus a common difference of 3, with a sub 1 being equal to 10, I can't calculate anything from this unless I know the term prior to the one that I'm looking for. Okay, so this doesn't really help us find anything out, it just gives us some information. Okay, the explicit formula here is a sub n is equal to a sub 1, which in this case is 10, plus n minus 1 times our common difference of 3. This is the explicit formula. Now, we can simplify this explicit formula because we can distribute the 3 to everything that is inside the parentheses. And so when we do that, we get that a sub n is equal to 10 plus 3n minus 3. So a sub n is equal to 3n positive 10 minus 3 is plus 7. And so if you notice that with an arithmetic sequence, when the explicit formula is simplified, that it is in the form of a linear equation. So I want you to realize that arithmetic sequences are linear. Okay, and so in this case, the slope is 3. Well, that's the same thing as our change here, that our common difference is 3. Because think about it, if you had the slope of 3, that's 3 over 1, that means you're adding 3 for every term, for every one term. You're adding 3 for every one term. That's what we're doing here. We're adding 3 to each term. Okay? All right, let's look at this next example. Here we are subtracting 2. So our common difference here is negative 2 because we're going down 2. So the recursive formula is a sub n is equal to a sub n minus 1. And then you could either say plus negative 2 or you could say minus 2. I would just write it this way. And then the first term is equal to negative 14. Okay, so that's a recursive formula. Explicit formula is a sub n is equal to our first term, which is negative 14, plus n minus 1 times a common difference of negative 2. Now, again, we could simplify this. We could say a sub n is equal to negative 14, and then I'm going to distribute the negative 2 here, and so that's going to be minus 2n plus 2. So a sub n simplifies to negative 2n minus 12. This would be the simplified version of the explicit formula. So it looks like a linear equation. And as you can see again, this is our slope, which is negative 2, which is the same thing as our common difference. Now, the explicit formula is good because if I wanted to find out what the third term is, or not say third, the 30th term is, I can say, I can plug it into either one of these. I could plug it into this one here, or I could plug it into the simplified one. And it doesn't matter to me which one you plug it in because you're going to get the same answer either way. Okay, I'm going to go ahead and use this one just because it's simpler to find or simpler to plug it in. So a sub 30 is equal to negative 2 times 30 because our n is 30 and then minus 12. So that means that a sub 30, or our 30th term, negative 2 times 30 is negative 60, minus 12 is negative 72. So the 30th term in this sequence is negative 72. Okay?